and welcome back to my channel. Today I'm going to be giving you a crash course on the definition of a limit. So normally when we're talking about a limit definition like this, we are looking to see what happens when we have a sequence an when n goes to infinity. In other words, this sequence an either goes to some concrete value or it goes to infinity or some other does not exist value. So the limit definition is for every epsilon greater than 0, there exists a big N in the set of natural numbers such that for every little n greater than or equal to big N, then the absolute value of an minus L is less than epsilon. So that's a lot of variables. Let me break it down for you. Epsilon is usually considered to be just a very, very small number. When you think of epsilon, think of like a really, really small number, like 0.0001 or something, like a really, really small number. That's our goal for epsilon. Let's say that the limit of an as n goes to infinity is equal to L. That is our limit. And that is going to be a value that we find when we look at our sequence a sub n. And our a sub n is just the sequence that we're looking at. Finally, little n and big N are the values that we are looking for to finish out our definition when we look at an example. But the little n is generally just the variable that is inside our a sub n sequence. So let's go ahead and apply our definition to an example. So let's say we want to look at this sequence an equals 2 plus 1 over the square root of n. So just by looking at it, we can see that when n goes to infinity, we end up with 2 plus 1 over the square root of infinity. So this is a huge, huge number on the bottom, which means that this goes to 0. And therefore, our claim is that a sub n goes to 2, that our L is equal to 2. So now we need to write out the entire definition. So here we go. For every epsilon greater than 0, there exists some big N in natural numbers such that for every little n less than or equal to big N, now we write in our an sequence and our limit. So that's 2 plus 1 over square root of n minus 2 less than epsilon. And now we only want to look at this final part over here. So you see here that 2 and minus 2 cancel out, so we are going to be left with the absolute value 1 over square root of n less than epsilon. Now we are just left with n in the left side, so our next step is to get n completely by itself. First thing that we can do is get rid of the absolute value because this fraction on the inside is always going to be positive. So we have 1 over square root of n less than epsilon. And next we can go ahead and flip the fractions, but remember the rules with inequalities. So this then becomes square root of n greater than 1 over epsilon. And then finally, if we can square both sides, finally get n greater than 1 over epsilon squared. All right, and we're really close to the end. So we want n here to be greater than or equal to big N. So to make this greater than sign into a greater than or equal to sign, we add 1 onto this side over here so that we can then get n greater than or equal to 1 over epsilon squared plus 1. And these brackets denote that we are taking the integer part of whatever this fraction is, because we are working with whole numbers, because n has to be a whole number. And then Now that we have n greater than some number, we can then set that equal to big N. We are done. Thank you so much for watching. This has actually been part of my final project for my math degree. If you have any questions, I'd be more than happy to answer them in the comments below. Once again, thank you so much for watching and have a great day.